Starting the record. Hello, everybody. We are in the mission 175. I am Professor Julio Rezende. This is the mission when we are celebrating the 55 years of moon landing. We have in this meeting in this mission some colleagues like Ira Sharma, Sharir Mozuku, Fidaus Shinabadi. I am Julio Rezende, and also two invited researchers, the Adriana Almeida and Celso Bandeira. Okay, we'll be talking about how would be the example of moon station, the how would be the operation of the main station on moon. We had one previous mission with participation of Dr. Sian Proctor, when she was one of the collaborators in the ideas of how this moon mission would be operating. Here we have like some stage of development of a space habitat. For example, if we consider the mission now we are planning to come back to moon. Uh, we like in the first moment we probably we will land only a capsule on moon like the plans of Artemis program. In this case, this capsule would present like a minimal crew also, but with the challenge to develop a permanent presence on moon. In the second moment, we have larger crews and more additional hardware, and also only in a third moment, like operational and also a crew and complete hardware, and also probably the sustainable exploration on moon. Okay. Yeah. Let me do a print screen here also. Yeah. Okay. Uh, what would be like the aspects of this station on moon? Here we have some ideas about the process of moon landing. Here's the representation of the Starship rocket, like an old concept, but the idea is one of the possibilities is the Starship transport like something like a model that would be transported to moon surface. Uh, the Starship presents like a large payload area that would be very interesting to be considered to transport some models inside. For example, here a representation how would be the process of uh, landing some components to build the station on moon, and this won't be one of the possibilities, and there is many other possibilities that are being considered, but the main issue is about how we suppose it the logistics system to be considered to land and to land on moon, and also to create the first infrastructures on moon. Uh, Also, based in our methodology for consider the ice station on Mars, we imagine that the Starship would transport some components like main seven components like a landing site, or like a mission control landing site, the main station, the health center, the greenhouse, the sanitation center, engineering center, and also energy center connected to kilopower generators and solar farm. We had collaborations with other researchers uh, related to internal design. We received a collaboration of architecture Brazilian student called Mariana Guerra, And Mariana proposed like not a circular shape, but like a hexagon shape. And she proposed it like a hexagon shape would be interesting because like a honeycomb would be connected. Also, this in our case, this would present like more safety maybe because we have like these models connected. And the components would be was these three different models we supposed to be called the alpha, beta, and gamma. Alpha would be like a place for resting and also with bedrooms and study rooms, the beta for entertainment and dining. And also the gamma is like a site where we have like the operation of the main office and also the supporting operations for all mission. These three models supposed to be operating here connected. Okay. Okay. In alpha model, we have like bunks. We imagine in total 28 astronauts in the entire station. It's supposed to be a place where they is supposed to be returning after the activities to sleep. Okay, also with two bedrooms, and two bathrooms in a study area. And also consider some plants aboard, like to evaluate air quality, also bring nature and connected to well-being, and also the possibilities of production of some vegetables to be used to prepare some meals. And a fourth characteristics related to importance of the plants is related to helpful for meditation. Some concepts of the dormitory and also the reading room, and also we are considered like here we have two examples for reading, like reading the physical books and also reading the digital books, and for stay well on moon. We imagine the importance about have like a great variety, like a digital library that will be consulted by astronauts. This would be a good thing in terms to develop skills and also entertainment. The beta model is supposed to be the place for like kitchen and also dining room, okay, and gym. Here is a virtual environment based and developed by Michael Lowry in Kitely. Okay, in in the kitchen. This is an example of a startup that developed a robotic system called the company is Molly Robotics, and this would be useful to prepare some meals and also have like a shelf with plants with artificial lighting to be used in the preparation of the meals. Example of dining room. This we imagine that the dining room is not big, and this would be important, like have some shifts of astronauts, for example, like uh, 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 s- seven astronauts dining in a specific time, and also other seven astronauts dining in other shift. And for example, because imagine that this infrastructure is not big to arrange 28 astronauts together. Uh, in the gym, we see some adaptations for the equipments. Uh, these equipments would be adapted to be used on Earth. When we are seeing here some examples of rubbers, some elastics that would be connected to be used in some Pilates activities, and these are in our missions on Habitat Marte or Lunar Habitat. We are using some these rubbers, some elastics for to develop some different activities, and these are one of the ideas how we can do some analog activities compared about the possibilities of exercise and workouts on Earth and Moon. Okay, in this case, all of these equipments are adapted to be used in a in an environment without gravity. Also about the internal design, the lesson model is the gamma. We imagine like one floor with research room, a second floor with training room, and a third floor with mission control. Here we can see the evolution of the control panels. For example, the Apollo missions, the all the instruments are all analog, analogic, and you can see the shadow introduction of some small screens, and now in Dragon capsule of SpaceX, like some like TV screens, like the systems that we are just using nowadays. It's interesting that we mentioned that the systems like operational systems we use it to control many activities happening inside the station. We imagine like something interesting, like a dashboard to control the entire station. You're observing the greenhouse, the power station, the health, the sanitation center. And for example, in the main station, it's important we control levels of water, food, temperature, humidity, and from the main station evaluates the external activities, for example, evaluates the conditions of weather, the temperature, lightning, or some possibilities of wind or dust storm, and observe the operations of the EVAs, how the astronauts are safe. And connected with the greenhouse from a station, we it's important we know the levels of oxygen and the water demands from the greenhouse and demands of energy for to keep the plants in a good conditions, and also from the kitchen, the chef of or in the main kitchen or in the kitchen, he needs to know some plants that are growing, for example, lettuce or cauliflower, and other plants that would be available to prepare the meals. And in this case, the in the main station, the kitchen will be contact the greenhouse to know what examples of vegetables that are available, tomatoes or peppers, and these will be interesting to prepare like the meals, because we imagine the meals prepared like combining pre-prepared foods and also the food produced in the greenhouse. Connected to health center, we need to know a lot of things about the mental condition of the astronauts and other health indicators. Connected to power station, we need to know how the quantity of energy generated from different sources, for example, the kilopower, solar, biodigester, and others. For example, one of the possibilities would be the microalgae that would be used to generate energy. Here in my university, we have a researcher developing microalgae to produce the biofuels. Okay, and it's also important to know the demands from the specific sectors related to energy, because the energy will be used to load the electrical vehicles, for example. And and also it's not less important. The sanitation center is like the heart of the station, because it's the place where is produced the oxygen, and also the water is recycled, If you have like a collapse in terms of oxygen produced, and the entire station would collapse. In this case, it's very important we have like no redundant systems, like also have like backup systems in terms of air conditioning, ventilation, and oxygen production, and also the air filtering and